Hey everyone, welcome back to the channel. So we were discussing problems from our binary trees ST sheet, and the problem that we are going to discuss today is level order traversal of a binary tree in spiral order. So this is the problem for today. I'll explain you what we have to do here. So just bear with me for today as my throat is not in a good state. Having some sore throat today. Okay, so let us start. Given a binary tree, your task is to find the spiral order traversal of the tree, which means what is a normal level order traversal? Let me explain to you. You already know it although, but let's have a look. So 1, 2, 3, let's say 4, 5, 6, 7, 8. For example, we have a tree like this, okay? A simple level order traversal looks like what? Every level you are moving from left to right and you are printing the value. So it will look something like this. On this level you will print 1, then you will print 2 from this level, then 3, followed by 4, 5, 6, 7 and 8, 9. Okay, that's how you're going to print in simple level order traversal. But the difference here is that you have to print it in zigzag order. So that means on the first level, if you are at level 0, let's say, you are printing 1, then on the next level you have to print it from left to right. Okay, what they have asked you to do is that on every level, which is, for example, this is 0 level, this is 1 level, this is 2 levels, so all the even levels are being printed from right to left and the odd levels are being printed from left to right. As we can see here, even levels are printing from right to left. Okay, so if you see 4, 5 right to left, 0, 1, 2 even level, right? 4, 5, 6, 7, 4, 5, 6, 7 is how they have printed. Okay, so simply the even levels are being printed from right to left and the odd ones from left to right. So how you're going to print it? 1, then 2, 3. This is then in the next level this is an even level node, so you print from right to left, that is 7, 6, 5, 4, and then in the next level you print from left to right, that is 8, 9. So you see the difference from a normal level order traversal and a zigzag level order traversal. So very simple. What you need to think here is that in normal case of a level order traversal, when you maintain a queue like this, right? So what you usually do, you insert the root value, okay, the root node, and then you remove it from the queue, you print it, and then you add its left and right children, right? You add 2 and then you add 3, okay, and then you remove it, you print it, then you add. Sound problem, let me check. What is the issue? Can you tell me? Is the sound okay now? Let me see what is the issue. Shouldn't be. Is the sound okay? Let me know if the sound issue still exists. Okay, so in normal level order traversal, what you do, you print, you remove, you print, and add their left and right children in the same order. That is, first you add the left child and then you add the right child. Here the difference is that you have to keep a track. You have to keep a track that which level you are at. If you are at level, or let's say you are at 0th level, in that case you have to print from right to left. So let's assign flag value initially false. So whenever your flag is false, we have to ensure that we will make flag false only when we are moving to the even levels. How will you ensure that? Okay, how will you ensure that? We are initially inserting 1 into your queue. So let's assume our flag at that point in time is false, and once you have inserted, okay, you make it true. Okay, let's say initially, because we start with root node getting into your queue, so let's make our flag true. So you can take it anyways. You want to make flag true when you are at even levels or true when you are at odd levels, that is up to you. Let's assume that whenever I move at an odd level, okay, I make my flag true. So right now I will check my flag is true. I will simply, in the process that goes in while I insert nodes into my queue, will remain same as that of a level order. So I'll just go and check. If left child is not null, I'll insert. If right child is not null, I'll insert. The only difference will come while I am removing the values from my queue. How? So I insert 2. I see that my flag is true. So first I will insert both the children. This has already been removed, and let's say you have one more array. This is an array which will finally store the answers. So right now your array has 1. Then you insert 2 and 3, and you make your flag false now. Your flag is false. Then, okay, now you take the first, what is the peak value of your q? The peak value of q is 2, okay? You have to check what is your flag value. Your flag value right now is false, which for me, I have taken flag in such a way, whenever it is true, that means I am at level where I have to actually take values from left to right order. Now if my flag is false, this tells me that whichever level I am, no matter how I'm adding into my queue, I have to finally insert into my answer array from right to left, okay? So as I see that right now my flag value, while I was inserting into this, it was definitely true. So I will make sure that whatever the size of my queue is, okay, I start from the last one. I start from the first value. That is simply you add all the nodes that are present in your queue into your array in the same order as they are, and then that is when you make your flag equal to false, okay? When your flag is false, you check again, you remove the first value of the queue and you add its left and right child. So what is the left child? 4. What is the right child? 5, okay? And then you check and remove this 3, add its left and right child as they are. 6 and 7 you add. But as of now your flag value is false. So whenever your flag is false, that tells you that you have to take whatever nodes are present in queue in the reverse order, because that is the order I would want finally into my array, right? So right now it is in this order, 4, 5, 6, 7. What all nodes are present in your queue, your flag will indicate. If it's true, I will take them as it is and copy it into my array. But if my flag is false, I will make sure that I start iteration, that is from the last value of your queue, okay? Whatever is its size, you iterate from the size minus 1th index, okay? And insert the value into your final array. So that will 7, 6, 5 and 4. Fine. So basically we are making use of two kinds of data structures here. One is queue, in which you are doing, there is no change, the way you are inserting nodes in a level order traversal, that's how you are inserting it here. The only difference is coming when I'm removing the nodes from my queue. I'm making it sure via my boolean variable flag. If it is true, I am ensuring it is true. I will take the values as it is and add it to my array list, okay? And if my flag is false, I will iterate from the last index of my queue and insert the values one by one into my array. That's all we are doing, and rest will remain same. So I'll just quickly, so what you can see here is finally our array list will look like this. And in the end, when you remove 4, you add 8, 9, right? You add 8, 9, then you remove 5, nothing is left to add. One by one you'll remove, and finally you'll see that your flag will become true. How it is happening, I'll show you in the code, but as of now the concept is this. I told you where the major difference is, so there is nothing more left to discuss in this question, because the only main point of discussion as compared to a level order traversal is when you're removing values from your queue in order to on the basis of flag value that you have chosen. Finally you'll get 8, 9. So that's what we actually wanted. It is like 1, 2, 3, then I have 7, 6, 5, 4 and then 8, 9. Fine. So that is your level order traversal in a binary tree. I'll just quickly show you the code, and then you can see, since we have repeated this kind of code a lot of times in our previous questions, like vertical order traversal and level order traversal, so this is not a new thing for you. So let's focus on what are the differences. So see, a queue, we have taken an array list, okay? Boolean flag initially is false, and as we do in my queue, I'm adding the root node, okay? I add my root node, then I start the iteration over my queue. Let me take this piece of code, and then I'll show you the iteration. You'll see the dry run, you'll understand it. Let's do a dry run over 1 tree. 1, 2, 3, 4, 5, 6, 7, 8. Let's say this is your tree. Okay, so let me do a dry run. So the dry run will be simple. Initially this is your queue. Let me take a queue as well. Oops. So this is going to be your queue. Let me take an array list. Final array list will be the one from, I'm maintaining a temp array list. Let's see your temp array list. This is your temp array list, and this is your queue. Okay, now let's see. Initially your queue contains 1. Fine, so your queue initially has 1, and your flag boolean, I have initialized it initially as false. Fine, so let's make flag, I'll keep the track of flag here, flag equal to false, right? Fine, now what, you check what is the size of your queue. It's 1. Okay, so this is your current node is 1. In your temporary, I am adding its data, which is 1. If your current node dot left is not null, which is 2, it is definitely, I have already removed it. Now I have added 2, and then from this line I have added its right child, which is 3. Then I'm checking. Right now my flag is still false. Okay, if flag is false, what I'm doing, I am actually, but ideally it shouldn't be. Let me see where we are. Queue dot poll. So for once, okay, so have a look. In my temp, I am keeping the track of my current node that I am pushing into my queue, because if you see, the current status of queue is that it has 2 nodes, but actually the one I removed is 1, and I have inserted into temp. Now what was my flag value? It was false. So I will iterate over my temp array. I will see what is the size, and in my temp, as I told you, whenever my flag is false, my idea is for false, I am iterating from right to left. Okay, and whenever it is true, my idea is that I am iterating from left to right, and I will finally add into my final array list. So my final array list will be, let's say here, which will have all the answers in the correct order in which I want. So in my temp, the size is only 1. I'll just from here, it will definitely not be removed. I can simply add it to my array list, which is 1 right now. Okay, that's all. And obviously you'll change the value of your flag, which becomes true right now. Okay, let's move ahead. Let's see now. Okay, now let's see what is the size of your queue. Queue size is 2 as of now. So what is the current node? It is 2. You'll add its left and right data structure the same way we used to do in level order traversal 4 and 5. Okay, but before you do that, and when you have done that, you also add it into your temp. Correct? Okay, now what, when you add this temp data structure, you see we have made, this is another data structure. We have made 2 array lists. One is your temp and one is your final array list. So as and when I'm removing any node from your queue data structure, I'm adding it to my temp, right? And you can see that flag right now is true. But before we go on that, first I have to complete this until I do it for both the nodes, that is 3, because that time my size was 2. I'll do it for 3 and add its left and right child. For 3, I'll remove it, add to my temp data structure and add its left and right child. Left is 6 and right is null. So that's all for this iteration. This particular iteration is done. Now what? Now you'll check your flag value is true, so you come at this. When you come at this, that means you have to insert values from left to right, whatever is there in your temp. Okay, so temp has 2, 3, so I add it in my answer. 2 and 3 will be added. Correct? Okay, now move ahead. Same thing is going to happen. I hope you understood this. In case you still have any doubts at any point in time, you can ask me, but this is what we are doing it. And what else? Okay, now the queue size right now is 3. So you can see one thing, in case you are wondering that 1 was not removed from the temp, then you need to understand that temp is a data structure that we are creating every time we are iterating in this loop. This while loop is always creating a new data structure. So basically we have an empty array, okay, in which as and when I'm removing the values from my queue, I am adding to my temp. That is why the desired values are being added into my final answer in the order on the basis of my flag value. Okay, now flag is false. So what is the size of your Q data structure? It is 3. So you are at this line, size is 3. So for 3 times you are going to insert its left and right data. So for 4 it is 7, for 5 it is 8, and nothing else. Okay, so you have removed 4 as of now. You add it to temp. So temp is right now empty. You add 4, fine. So then you add 5, then you add 6. That is the end of iteration for this inner for loop. Okay, then you check what is the value of flag. Flag is false. Whenever my flag is false, it means I want to iterate over my temp array from rightmost index to leftmost index, because that's how I want the values to be inserted into my final answer. I want values as 6, 4, 5 and 4. So I'll go with the last index, as you can see here, temp.size -1, and add it to my final answer, which will become 6, 5 and 4. And that's all. Temp's task is done. It will be removed now. Again, you go and iterate in this first while loop. You'll check what is the size of your Q. It is 3. You again insert these values one by one into your temp array, which is again a new temp array list, in which you'll add it 6, 7, 8. Okay, and yes, your flag was true before we came at new iteration. When the flag is true, you simply add all the values that are present in your temp array into your final array list, that is in the same order, 6, 7 and 8, and that's the end of it. Fine. So as now you can see, we have done the dry run 1, 2, 3, compare it with this array list 1, 2, 3. Then I want 6, 5 and 4, which is correct, and then I want 7 and 8. That is fine. Okay, so that is all about this problem, guys. If you have any doubts, let me know. Otherwise, we will wrap it up. So we are done with this question. I hope you all understood it. It was also a simple problem, and also it's just not only one approach. This is just not one way in which you can do. You just have to ensure that how you are traversing at odd levels and even levels. So here I have made use of Q data structure and flag. You can also take 2 stacks and think of it. How can you do? Because stack can solve purpose, can remove the need of a flag, but we are taking just a flag variable, and there we'll have to take 2 stacks. So I think anyway the space complexity will still be same, because here instead of that 1 stack you have used 1 array list. So anyhow it is going to be same, but yeah, you can think of it in that way as well. So I'll just wait for a few seconds, and if I'll see no doubt, we'll wrap it up. Okay. So that's all for today, everyone. See you all in our next lecture. Bye bye and take care.